Uh-huh.
Yeah.
Hello.
Shut it off.
Okay, here. Oh.
Hello. That's much better. All right. Welcome to Carl's class. My name is Craig Barbieri, and I'm on the Build Committee for DTS, the Design Technology Summit. If you're not aware of that, check it out. So you guys probably know Carl. He's a fixture at Build. He's been around for a long time. Just want to. In the industry for almost 20 years, teaching and doing what he does, helping the architecture, engineering, construction industry get better and better. Very well known for his fantastically informative classes, which you're in one. Congratulations to you all. Fun fact about Carl, he's one of the few speakers who's spoken at every Built conference around the world last year. There were 3, 4 people who did that. One was a sponsor.
Yeah. Kelly doesn't count.
Kelly doesn't count. So you're in good hands. And the other fun fact, this was really interesting for anyone who likes Legos. He won the what was it, the 2020 20 minutes, 20 slides, Vision 2020 presentation competition last year in Brisbane. Okay, thank you. And the prize, came in second, but the prize was a 40-pound Lego Millennium Falcon, which he had to buy a whole new set of luggage to get back to the United States.
Worth it.
So with that, I'll turn it over to you and enjoy yourselves.
Thank you very much. Thank you very much. Can you hear me? Is this thing on? All right. Yes, it was awesome to win the Millennium Falcon, but if you're going to win a big prize, maybe not as far as possible away from your homeland, but it was worth the extra suitcase. All right, I have a lot to cover in a short time to get there. That's for you, Bill. So let's get started. We do have AIA credits, so if you're looking for an easy way to get some credits, this is it. Learning objectives, they're in the handout. Oops. Yes, thank you, Bill. Thank you. If you want to get a hold of the documents, they're on the app. We, as speakers, like to tweak it to the last minute, so I literally just uploaded version 3 of the PowerPoint slide. I added a few things this afternoon. So it's on the Dropbox. It will be on the app when they reload everything. A quick look at the agenda. Some introductions, although Greg did a great job. That funny-looking guy whose clicker is going ape crap bananas is me, wearing the same shirt. Not awkward at all. Always a little awkward to talk about yourself, so a slide does it for me. So there we go. Now let's get into the meat of the presentation. Or not. Wow. Come on, clicker. Let's just sort of pull. Give me a second. All right. What the heck? All right. So, tailored expectations. Spoiler, you've already seen it. The idea is, from this class, you are not going to become a computer scientist. You won't be a programmer. You won't be a coder. You won't even be a hacker. So if you were expecting any of those things, I won't be offended if you get up and walk out. Or if you just have a little snooze in the back. I did turn on the mood lighting for the presentation, so I know we just had lunch. What inspired this session? And what inspired it might help you understand why you won't be all those things. So last year in Ljubljana for the Built Europe, I attended a class from Gordon Price. And as part of that, there was a Twitter exchange with Aaron Muller, as sometimes happens. And he basically said that if we don't have a computer science degree, we're not coders. We Google, we tweak, and we get the hell back to work. That's what we do. And that sort of inspired me for this class. The idea is that we're not here to become somebody that has a computer science degree. We're here to learn a few things along the way that might help us fix something real quick, and more importantly, know when we can't fix something real quick, and we need somebody that knows more than us to do it. And wow. And there's the actual exchange you can see that came in place. So, what we will get from this session? So, a lot of resources. In the handout, I've got like 8 pages of links to things. Anybody that goes to my websites know I'm a little crazy for the links. We're going to go through some examples later on, and we're just going to try to get a little bit better on our own journey to getting those codish skills. Now it's not working. So, what we're going to get from that is at the end of this, we are all going to start our own journey so that we can all get our black belts in being a codish ninja. And if you like bananas, that's sweet, pretty sweet. If you're looking for something a little more, now this slide is a great slide. Unfortunately, all of the classes I'm talking about have already happened. So attending them isn't going to help you out, but the information that comes from them very will. And I attended all of these sessions. The one yesterday by Dan, he tweeted out the GitHub code. So if you're looking for the code, it's hard to read on the slide, but you can go to the tweet or just go to Dan's handout package. He has a link to it. So the actual code is available. So there's lots of great resources out there from this week to help you get more coding than you're going to get here. So anybody that's attended any of John Pearson's classes where he talks about his Dynamo journey inspired me to talk about my codish journey. You may not be able to tell from my young boy appearance, but John is much younger than I am. So my journey started a little bit earlier than his. So, yes, in the 80s. Thank you, Robert. Is anybody familiar with a language called Logo, or everybody affectionately called Turtle? So back in 1984, I started playing in the local library on a TRS-80, and I did some Logo. I could make little charts and graphs, so it was pretty cool. I think it's been 5 minutes. I'm already going down the first rabbit hole of the session. So, worth it for sure, though. You can go to the Turtle Academy, which is a real website right now, and you can learn Turtle without having to have the TRS-80. If you do have a little bit of coding chops, and say, for example, you use Visual Studio, well, there's an actual add-on to Visual Studio that allows you to do Turtle right inside of Visual Studio. If Python's more your thing, well, guess what? There's an add-on for Python 2. There's an add-on for Python also. Python has an add-on. Hey! That allows you to do Turtle. So, Turtle. The next year I upgraded my stack. I get a sweet VIC-20 Commodore with a tape drive. Some of you in the room may not be old enough to know what a tape drive is, but there's what it looks like. You go to your local library or the after-school book club, you you physically bought, no more downloads, the book, and we would type in some code and we'd get some, on the trail to Oregon type game. So I'm thinking this coding stuff's pretty cool. There might be a future here. So fast forward a couple years, I upgrade to the latest hardware on the market, the Commodore 64 with floppy drive. But at this time, the games are really starting to kick it up a notch. Those 8-bit graphics were kicking my ass. So I had this sweet game called California Games, and so I stopped trying to code stuff and started just playing some sweet, or I should say, period correct, rad BMX games on my computer. In '89, started high school, I tried AutoCAD for the first time, and I thought, no. I don't need to code, I just do everything in AutoCAD. I'm going to become the world's next premier CAD monkey. And so I thought, this is what I want to do. I'll put the coding aside. I'm just going to take a look at AutoCAD. Now, for some of you that may not have been around back then, this is a floppy disk. Release 10 is what I started on. 4 floppy disks for the entire program. Think about how many gigs you have to download now to make it work. And in reality, not a lot's changed. This is also the beast of a 386 machine that I used with a sweet, sweet tablet/digitizer, where the ribbon is on a piece of plastic, you stick to it. Awesome sauce, awesome sauce. Okay, so now we jump ahead, we get in our time machine, and we're going to take a look at the 2000s. So we're going to come back into current times. So 2008, I stopped being a CAD monkey, started being a BIM ape with Revit. I thought, okay, this is where I want to go, this is what I like. 2014, I attend my second RTC, and I take a Dynamo class with Marcella, who I just saw walk in the room here, and I thought, yeah, this is kind of cool. I don't have to know any syntax. I don't have to learn sort of any language. I can just take some spaghetti-looking things, plug them together, and life is good. The following year, I take Harry Madison's class on the Advanced Revit API to learn what the Revit API looks like, a little C++, and maybe get into what we can do with macros. 2016, I teach my first Dynamo class. So what I would like to speak about that is, it was an introductory class, but the fact that these communities, events that we go to like Build, you really can learn something and then start sharing with everyone else. So I'm by no means the expert that Marcelo might be, but the idea is that I learned enough, and you learn so much more by knowing that A, you have a deadline for your handouts, and they come after you if you're late, by the way, and that you're learning to teach somebody else. So the process of writing down your ideas and taking screenshots and going through the data set really cements the thing in your head. So if you're thinking about how can I learn, do a lunch and learn for your office. So 2017, first Python class, went to the Advanced Dynamo Workshop at AU. 2018, I did some Python classes, C#, design script, all that stuff all over the world for the build sessions. So I'm starting to say, okay, I've been to a lot of classes, I've got a lot of handouts, maybe it's time to put on the big boy pants and take the dive. So this year I enrolled in my first continuing ed university class, C# to actually take some programming. And I think why that worked best for me is because I actually had to pay real money and I had deadlines. It's amazing how much when you separate your money from your wallet that you start paying attention to what you need to do. And that brings us to this week. I was fortunate enough to take part in the DBEI hackathon. So I was on team Hack and Black, Jason, John, Marcelo, myself, and Adam. And we created something that was pretty damn cool, called the DAM, the Dynamo Asset Manager. And another way to really sort of put your toe into the waters of coding and learning is a hackathon. You don't have to be a coder. You don't have to have skills. Everyone works as a team. You do what you can do, even if it's just a prototype idea. But everyone that's in the room that's all working together, you learn so much stuff just through almost osmosis by doing that. And in the spirit of sharing, because John was on our team, he has already hacked out the GitHub repository, so if you want to get the DAM extension and play with it, it's out there for everyone to have fun with. So, where do we start? How do we begin this journey to getting enough skills under our belt to at least know that we don't have enough skills under our belt? We go to Target and buy a clicker that works. So, resources. These are the resource pages from the handout. I broke it into 2 parts, so there's coding resources and Dynamo resources. Truth be told, I had the Dynamo resources from my other Dynamo classes, so a little extra thrown in there. But tons of things to help you along the way depending on where you want to go. So, books. Yes, people do still read books. Maybe digital, but they're still there. Some awesome books that I found really helpful up here. C# for tweens and teens, and Python for tweens and teens. And I get 2 responses when I tell people that. They laugh, or they say, well, I'm an adult. I go to work in the morning. I can't read a book like that. Fair enough. There's an adult version. But I really like the smaller ones, different form factor, and you can do it under the guise of, I'm learning this with my son, my daughter, the neighbor next door, the kid in the local community center, whatever it is, and you can learn together. They'll probably teach you a few things about computers. But if you prefer the adult ones, they're up there as well. Of course, There's tons of books out there to help along the way. I have a lot of them in the resources. I don't list them all, but one that I do want to call out particularly is Thinking Like a Programmer. It's actually a C++ book, but it's written to help you learn to problem solve. So while there are computer examples and there is example code in it, it's the way that it walks you through the idea of thinking about a solution in a way that computers need to think about it, the way the language needs to think about it. So one of the hardest things that I have with trying to code is I'm not a logical thinker. I'm not a left-brain thinker, I'm not a right-brain thinker, I'm kind of a snooze-in-the-middle type of thinker. But the idea is that you need to have that mentality of the way that you think like that, and this is a really great book to give you examples and walk you through real-world examples before it gets into the coding. Videos. More of the speed for this day and age, and of course when videos are around, we all go to our friend at YouTube. A couple of the resources that I used to start this journey. So the first one that I went to for C# was this gentleman right here, Michael Reeves. I do have the not safe for work on there because he tends to be a little potty mouthed and have a lot of energy drinks when he's doing the videos. But that's kind of what made it engaging to me. You know, it's 4 short videos, but it's sort of in the way that it was delivered. If you drop the F-bomb in the first 30 seconds, maybe it helps you pick up and remember what he's talking about and the syntax. If you want something a little more not that way, this is CS50. This is the most popular class at Harvard. They have over 800 students every year, and it's an overall general computer science class. Anyone can go to the YouTube page and take part of it, or YouTube channel, and take part of it. And they do things a little bit unorthodox. They sing songs, they use puppets, and they use the classic example of peanut butter and jelly. So at the beginning of each year, they ask some unexpected students to describe to the professor how you make a peanut butter and jelly sandwich, and then he does it exactly as they say. Things happen, not peanut butter and jelly sandwiches, and we learn the value of how we have to think when we program. Full disclosure, a little bit later, we'll do the same thing with coffee. There's also a couple that are more sort of industry specific or Revit specific. The PyRevit YouTube channel has some great stuff about working with Revit and Python. And Danny Bentley has an awesome channel if you want to learn anything about Python or C# inside of Dynamo and Revit. So some highly recommended resources there. When we get into courses, there's tons of things out there. I've tried them all. Self-paced, lecture-based, tutorial, academia, as I mentioned. Putting your money where your mouth is and actually paying some big bucks for something tends to motivate me. Udemy, one of many paid sites there to get it. I mentioned this one specifically because of Harry Madison's 2 classes about the Revit API. So if you're working with Revit specifically and you want to learn, definitely worth the investment for his 2 classes about the Revit API. EDX, it's Microsoft's free learning site. The classes are free. If you want a certificate at the end, you give them some money, they give you a certificate. LinkedIn Learning, I know it is lynda.com. Lots of great stuff in there. The one that I'm showing is Jeremy Graham's LinkedIn class about Python and Dynamo. Solo learning. Now this one, a lot of people scoff when I show it, especially when I show the mobile app version. But it allows you to do simple tutorials on your phone anywhere. So when I'm taking flights from one conference to another or from one business trip to another, I have the app and I can go through and try to answer questions about C# or JavaScript or Python. And when you answer them, you get to keep that stuff in. And the nice thing about doing it on the planes is you can't get to the comments because everybody spoils every question by putting the answers in the comments. So on the plane, I can't do that. I have to actually use my head. And once you've finished, you have that really easy to access repository of information about what are my operators, how do I write a method inside of C#. It's tiny little easy bites of information that you can have to get. So, also free. And of course, the academic world. I'm from Calgary, so I take my classes from the University of Calgary. Lots of places where you can take academic classes. Why this helps me is there's deadlines, there's homeworks. If you don't pass, the company doesn't give you money to take the next class. So, you know, there's things that you got to do to make sure it happens. There's also a difference between a 90-minute class online and a 90-hour class plus homework that you have to take. You definitely get much, much deeper into the weeds and the content. So, I mentioned we were going to talk about programming and how it's like coffee. And we're going to talk about it with my friend Terry Tate.
Hey, Laura.
Hey, Paul.
You know you can't bring that weak ass stuff up in this Humpty Dumpty. You killed it, Joe. You made some more. You know that, baby.
All right. So you don't want to upset Terry. You always know that when it's time, you make the rest of the coffee. But let's talk about that in programming language. The first time I heard this analogy was on BIM Thoughts, episode 35, with the great Bill DeBevick. Starbucks is just on here because we're in Seattle and I need to fill up some white space. But honestly, go check it out, that podcast. It's what got me to this next analogy, which has always stuck with me. So you drink coffee. That's the first question. You get in the office in the morning, you're standing in the kitchen, you're looking at the coffee maker. The first question is, do you drink coffee? So if your answer is no, walk away. Program done, we're finished. If after last night's event, you definitely need the coffee, then we've got a different suggestion. So, yes, how much coffee's in the pot? First subroutine we gotta run. None. Empty. Well, that's fairly easy. Then we know we have to run the routine that says, make a new pot. Pretty clear and simple. Half full. Sweet. We just fill our cup, we go back to our desk, all done. A little more difficult. The elusive some. We don't want Terry to get us. So, we put some in our cup, but we run the nested routine of also making another pot. Again, we fear Terry. Full pot. Seems like a simple solution. However, remember, it's first thing in the morning. Is it from yesterday? No. Sweet. Drink up and we're good to go. But what if it is from yesterday? Do we have time to make another pot? Sure, I don't want to start work anyways. So then we just make another pot. Go into a meeting, have a deadline, so we don't have time. Off to the microwave, we make do. So this kind of gives the idea of how you have to think. It's not just as simple as grabbing the coffee and going. We have to logically plan out every single step. And going through the idea of graphing it gets us to that next step where we know what's going to happen. So now that we know it's like coffee, where do we scratch? And 3, 2, 1 for pun. So we start from scratch. Does anybody know what Scratch is? Thank you. So Scratch is built by the brains at MIT, which is a little visual programming tool that helps you to code. Again, designed for kids of all ages. There's the caveat there, kids of all ages. That allows you to use something like Dynamo, very simple plug-and-play interface, to go through the process of learning how to code. You can even bring in your own sprite, as they call it, and get your mug on the tool. So you know that's worth the price of admission right there, which is free. If you're looking for, again, a little bit more adult solution, you haven't quite dived into Dynamo yet, what we can do is we can go to Tinkercad. Autodesk now owns Tinkercad, but they've just recently come out with what they call code blocks. So it allows you to use the same visual programming idea to create 3D objects that you can then use as a 3D model, or you can even use it to print out from there. So that's another solution of where we get started with that visual programming idea, where we don't have to learn syntax, we just have to plug things together like Lego. So the next thing is, what language do we want to use? And so when we're talking about computer languages, they're very similar to spoken languages. So when you think about English versus, say, Greek, English is like that blunt object that we use. We have a lot of slang. It's very hard to learn even if it's your first language, and things don't always mean the same. Greek is much more elegant. For example, they have 8 words for love. Well, why does that matter? Well, we might say we love pizza and we love our spouses. In Greek, if we say we love pizza and we love our spouses, we get funny looks because they have different words for that, different things. So languages, computer language, work the same way. Choosing the language that's going to be most appropriate for what you want out of it. But before you can do that, you've got to have at least some idea of what the languages are. So, some of the languages that I chose to speak about in very, very high level are what we see here on the screen. They're ones that I either know about or interacted with in my role as an AEC consultant. There's tons more out there, C#, PowerShell, Ruby, the list goes on and on. But these are some of the ones that I just wanted to bring to your attention that I've run into that you might find is a good place to start. Grasshopper. Never actually used Grasshopper, but I've heard a lot about it and I've seen some really great things. And if you're a Rhino user, which I'm not, it really falls into your wheelhouse. Dynamo, also a visual programming language. I have used Dynamo. I enjoy it, but like a lot of people that come to any of my introductory classes on Dynamo, sometimes I struggle with finding which node is the right node. They're not always named in an intuitive way. Sometimes maybe that's the person that made the package or the people at Autodesk that put together the node. More than likely it's the people from Revit that put together the API way back when that call something completely different from what it was. You just need to sort of know what you're getting into, and then it becomes a little bit easier. Design script is the embedded language inside of Dynamo with what you use. So if you happen to use one of those lovely double-click code blocks, this is the, I guess, natural syntax or language that you can use inside of there. And it's called design script because it was meant to be easy enough for designers to read. I didn't make that up, that's just what they said. So that's the idea, is that the syntax is very easy to work with. AutoLisp. Yes, it's a language. It's also a dying art. As a consultant, we get a ton of requests for people that have 20-year-old Autolist routines that they need to update, and I can't find people that still use Autolist to update them. So if you're looking for a cottage side industry and you know some Autolist, hey, there's people looking up there, I guarantee it. Forge. Okay, so Forge isn't really a language. Forge is actually a cloud-based process that allows you to take 2 languages or APIs and tie them together and make them shake hands. But we've heard a lot about it here, and if you're going to be at AU, you're going to hear a lot more about it. So if you're learning any of the other languages that we're talking about, then Forge will come into play. But technically, it's not a language on itself. Visual Basic, or VB, very similar to C# or C++. It's not used as much now, but it's still a very relevant language that's out there. JavaScript. I came to know about JavaScript when they updated Format Pro beginning of the year, and you now have the ability to write your own add-ins or plugins for Format Pro using JavaScript. So I thought, hey, I should learn that. And so I used a little solo learn, and I learned enough to know that, hey, this is really cool, but I should actually stick to one language and learn it. And I chose C#. Python. Ton of Python talk at this conference. I think it's not the fastest, it is going to be the fastest growing language out there. It's really easy to learn. Again, I'm going to do easy in quotations because everyone has a different idea of what easy is. But the syntax and how it works is very user-friendly. If you've learned another language, getting into Python is very user-friendly. And a lot of us here that might work inside of Revit would be maybe more familiar with the .NET version of it called IronPython. So this is what comes with Dynamo when you install it. This is what lets you talk to Python scripts directly inside of Dynamo, is IronPython. So same syntax, just built off the Microsoft .NET framework. And C#. So this is the one that I'm learning now, trying to actually focus on. A lot of the times it's really the syntax that is the difference. Once you learn the syntax, and as we'll see a little bit later on, once you learn one language, other languages become a little bit easier to learn, because a lot of things are very similar. So one of the things that comes into play when you're choosing a language is what you're going to want to do with that language. Am I writing a massive program that I'm going to use all the time and I want it to be super efficient and super speedy after it's written? Am I working inside of Dynamo and I want to very quickly test some things and be able to run them and see what's going on the fly? So if you're looking for that on-the-fly mentality, you might be looking at Python because it's interpreted. If you're looking for that stable long-term, you might be looking for C# because it's compiled. So what does all of that mean? So we need to have the person that's creating the code write the code in whatever language you want. And then we need to convert that, either interpret or compile, into machine language. Now, I heard someone say this, and I scratched my head for a bit, but then when you think about it, it's true. The reason we have to convert to machine language is because computers are essentially dumb. They can only read ones and zeros. So we can write it in whatever language we want, then we use our mechanism here in the middle, which converts it to the machine language, and then lets the computer execute those commands. It's just whether or not we want to do that on the fly, or we want to do it for the long term. And so this is kind of an example of the two, and again, you'll see that I'm going to talk mostly about Python and C#. All those other languages are definitely out there, but those are the two that I'm going to use for my examples for the rest of the presentation. So Python, cross-platform, doesn't have to be on a Windows machine to run. C#, not cross-platform, need to be on Windows to make it work. We have the ability to make everything, the C#, it compiles the code, so everything. Whereas when we do the interpretive language, it runs through line by line. So the more code you have, the slower that it is. It goes through, and we can say that right here, often slower, often faster. And often is the caveat for my little CYA, if you have different experiences than that. But then we also have more flexibility, the idea that we can always tweak it and turn it without having to build the solution, having to run the solution, have to go through and do all that debugging. So it gives us a little bit more flexibility. And again, those are your options. Those aren't the only two options, or so the only two programs that work with an interpretive or a compiled language. But it gives you an idea between what those two things are and what they do. Stop using clicker. Anytime I get a chance to throw in an XKCD comic, I absolutely do. And so if you're looking for that extra thing to push you towards a compiled language, maybe some built-in slacker time will get you there. And as you can see, compiling my code is a totally acceptable answer to have to have desk chair fights with swords. So, IDE, I don't even. What is an IDE? Good question. So, when we're writing a code, we could use an integrated development environment where we're going to put the stuff in. We could also use any of these products. And these are just three that I either have or heard of, and there's a ton other in there. And I know people are going to give me some grief about this Python one in the middle, but let me explain when I get to it. You can also have a code editor, a text editor, another group to choose from. And then, in this case, I'm going to use Rev as an example. We also have the ability of doing some editing directly inside of the platform. So whether we're using the Sharp development for doing some macros directly inside of Revit, we use the add-in of the interactive Python shell, which is an add-in for Revit that allows us to get into Python directly inside of Revit. Or we go the Dynamo route and we can do some design script or some Python scripting directly inside of Dynamo. So as I mentioned, some of these I have had some interactions with, and so I'm going to briefly go through and give you my knowledge of them, and brief is an understatement. So Visual Studio. Visual Studio is kind of like the full meal deal. It gives you everything that you want, and luckily Microsoft knows there's a lot of us out there learning that want the power of a full-service integrated development environment, but don't want to pay for it. So what I use is what they call the Community Edition, completely free. Of course, there's a paid version and an enterprise version that have a few other bells and whistles, but for the stuff that we would typically do in the AEC industry, the free version has more than enough than what you might need. The IDLE, so the Integrated Development Learning Environment, is what comes with Python. So when you go to the python.org website, you download the latest version of Python, this comes with it. Many people would say that it's not actually an IDE, it's more just Text editor, I like to think of it as an entry-level IDE, whereas some of the more advanced code editors go the other way. But this is where I put it because it almost spells IDE, so that was my reasoning behind it. When we get into code editors, I think 3 years ago now, Microsoft came out with Visual Studio Code. And a lot of people were like, what is going on here? Because it is just a fancy text editor. It does have some of the benefits of an IDE, meaning it's got IntelliSmart, so it tells you things if you're typing the wrong stuff or if your code isn't going to work. It is cross-platform, so you can use it on any platform. You can also code pretty much anything in it. There's an extension for Python, there's an extension for Ruby, there's an extension for C#. You name it, you can do it inside of here. Notepad++, another free product, so Code Studio is also free. A free product that everyone should have. It's definitely better than Notepad that comes with Microsoft, and it also has add-ins and extensions, so you can pretty much do any kind of coding in it you want, at least to quickly get into something and edit it. And remember, the whole purpose of this session is we Google, we tweak, we get out. Notepad++ is going to become your best friend for that particular scenario. Now, if we're doing in-program, Sharp development is what comes with Revit. So again, if you're working with the macros, anybody here work with macros in Revit? See a few hands up here. So this is where you would do your development directly inside the program. We've got the interactive Python shell, an add-in, also free, that you put into play and have it run. You may notice that all of the solutions that I talk about are the free ones. We talked about how I like to keep my money in my pocket. We talked about working with code blocks. So this is a code block inside of Dynamo using design script. This cool little script, this few lines of code, will actually go through every single package on your package repository and tell you whether or not it was created in 1.3 whatever or 2 point whatever. And if you've ever had that issue where I have a package and I try to open it at 2.0 and the whole world crashes down, this solves that. I did not create it. Jacob Small from the Dynamo team created it, so there's a link to the Dynamo forum in here where he shares that little piece of code to put in. It's super helpful when you're trying to suss out your packages from the old and the new. So by all means, share it around. And then what it looks like to interact with the Python script directly inside of Dynamo. This particular window, did anybody take John Pearson's class this morning on Python? So this particular window is the new 2.0 Dynamo window. So we have the ability to run directly inside of it. We don't have to save our changes and run just the graph. It also stays open, which is really cool when we're working through the process, whereas the old one did not. So now that we've talked a lot about programs as far as languages, the next thing we're going to talk about is the API. So what is the API? So it's the Application Programming Interface. And no example would be complete if we didn't talk about coffee. So this, again, we talked about the idea with this class is Googling, getting it done, moving on. Well, that also means sharing information you learned from other presentations. So Mark Thornley did this class at AU last year in London, and he graciously allowed me to reuse it because the coffee metaphor works so well. So we walk down to the local Starbucks. As a customer, we have cash in hand. We want some coffee. Between us and the coffee is the cashier / the barista that needs to make that transaction happen. We go to the cashier, we give the cashier cash, the cashier gives the order to the barista makes the order, gives the order back to the cashier gives it back to us. That is an API. And to prove it, it says so right there on the screen. So that's really the idea. It's the in-between to get you from one point to another. It allows these things to talk. And it's become a big thing. Well, it's been a big thing, but we hear a lot more about it now, that all of the companies are deciding that they can't make every piece of software do everything. We might need to start sharing some information between our applications. Some other places to get some helpful information about the API. Again, Revit-centric. If you're working with the SDK, and it's the Software Development Toolkit. SDT, I guess, didn't work, so they went with K instead. But what this allows you to do is to download everything about that particular API. And every year it's a little bit different, so it automatically comes with your software. You can go to that little link in the bottom corner and choose all the different versions that are available out there. There's also the Revit Developer's Guide. So I've seen this in a couple of classes already this week. They actually have a guide and will walk you through making your very first Revit add-in. All of that's out there. You don't need to learn from scratch. There's people there to help you out. One of my favorite tools, the Revit Lookup add-in. So this basically is an add-in. Again, boost your BIM. Jeremy Tanek is the one that came up with the original source code, and every year he updates it. Harry Madison at Boost Your BIM made a nice little installer, so you don't have to worry about the source code. You just hit the installer, and it will install from 2017 to 2020. And this allows you to essentially, as the little add-in says, to snoop inside of what you're looking for inside of Revit. So you select an object inside of Revit, and you can snoop through and find out all the coding information about it that you could ever know and want. And usually that's where you find out that, for example, like we all know that a door number is under marked, but why the heck is it called marked? This is where you get to see behind that curtain and I was about to say understand why they named it like that. I'm not going to go that far, but at least you start to put two and two together why it has a different name. A couple other quick resources, Revit API docs, lots of different versions, type in what you're looking for, spits out what you need. The same gentleman that made this has also expanded to API docs, which give us Revit, Grasshopper, Rhino, and Navisworks APIs as well. Again, community application where someone is spending their times on evenings and weekends to make sure that we have the ability to learn this stuff. All right, coding 101. Some quick coding ideologies, and then I promise we'll get into an example. So, start by making a plan. I wish I had had this simple website when I started down my road, because it tells you some things to pay attention to. One is the fact that the magpie approach. I mentioned, oh, I'm going to start learning JavaScript. Oh, I'm going to learn Python. Oh, C++, I heard that somewhere. C#. You're never going to get any good at a language if you don't spend time actually learning a language first. Nothing wrong with learning multiple languages, but if you learn one first, the chances of success are much better. Also the idea of actually spend time programming. That's where taking the actual course for me worked because I had homework and I had to do it. Watching a video seems like you understand it, but 3 hours later if you try to put it to practice, for me, it's gone. So I need to actually spend time doing it. The other thing I like about this, and unfortunately the whole article won't appear on the slide, is that it starts at 0. So when he gets to 25, it's actually, there's 26. We need to learn about zero indexing. So keep that in place. We need to start with a problem. Going to classes is great. Learning stuff online is awesome. Going to a big paid environment, great. Where you really start to learn is when you have a problem that you want to solve. Because when you have a problem that you want to solve, you know the details of the problem intimately. So you're not thinking about the problem and trying to think about how to code it at the same time. So the problem is, I need to get from A to B, I know that, now I need to think about how to code it. If somebody says, you need to get to A to B, but you're really concentrating on getting to C, the problem isn't really relevant to you, and you're not really putting all your thought power into it. So we begin by figuring out what the problem is. Before we write any code, we solve the problem. We don't solve it computergrammically. That's a new word, got to trademark it. But, for example, we need to copy a door inside of Revit. We know how to do that inside of Revit, so we know the solution to that inside of Revit, but we want to do it multiple times, so we would like to write a little Dynamo graph for that. So we know how to do it in the interface, now we want to learn how to do it in Dynamo. So that's what I mean by knowing the answer first. Once we have the solution, that's where we start saying, okay, we know how to do that, now we need to put it into a language that the computer understands. That machine code or binary. Silly dad joke coming in 3, 2, 1. There are 10 types of people in the world. Those that know binary and those that don't. Thank you. I'm here all week. So, one of the things that we can do is we can make a plan. So we can do this by doing some flowcharts, or we can do it by using pseudocode, which is a big fancy word with letters that don't make sense, to tell you how to write something out in plain English. So when you're using your pseudocode, you may just write down the steps that you want to follow. You may use some of the initial syntax that you would use in the language. You may not. But the idea is that you walk through those steps, you solve that problem. Just like the chart we did for coffee, you go through the idea of how we put things together. So again, you have a plan of attack as you're moving forward. Good code is commented code. So when you're working with your code, put comments in it. If you're going to share with somebody, they'll appreciate it. If you don't use the code for 3 months, you'll appreciate it, that you put in the comments what you were thinking. And so if we're working with C#, a couple of slashes. With Python, the #, hashtag, whatever you'd like to call it. If we want to have multiple lines of comments, we can do that in C# with a slash and an asterisk and then closing it out. There's not really a way to do multiple line comments inside of Python. I know someone out there is going to say, but I can do a multi-line string. Technically, yes, a string is not a comment, though. At least I've been told. Variables. So this is your bucket where you store the data that you're going to use. And I was conveniently enough able to find a bucket full of 1s and 0s, taking it back to my binary. So we need to give it a name and we need to give it a data type. A data type, string, a data type int or integer. So built is a string, 33 is an integer, it's a number, it's a whole number. Variables are case sensitive. So you need to make sure that you're using the proper case. We can have numbers, but they can't be at the beginning. We can't use spaces, and we can use the underscore if we want. So that's why you see a lot of underscores. String. That cat is very creepy, I apologize. Strings, just basically text, is any sort of character that we put into place. So there are some strings inside of C#. When we have a string in C#, we use quotations, or double quotations, if we do it. You can see that I have 33, which to the trained human eye is a number, but because when I put it in quotations and it tells the computer says this is 2 characters, a 3 and a 3. It is not an integer, a number, a double. It is just like the T and the L. When we get into Python, a little more loosey-goosey. Do you want to use 2 quotations or just apostrophes? Whatever you want. We're easy here. We talked about the triple quotation marks to have multiple line strings. Again, not a comment. And the same thing, we can have numbers that are strings because they're put inside the quotations or the apostrophes. Numbers. Oh, brick. We have a ton of numbers inside of both. I don't go into very much detail here, but some examples, int or integer inside of C#. It's a whole number, no decimal. The number in brackets is how much information it can store. We get into a float, basically like a double. What's a double? Well, a double means that we have stuff in front of the decimal and stuff after the decimal. The difference is how much information or storage it will use on your machine for C#. So one gives us 32-bit, one gives us 64, and there's a lot more after that to give you even more storage when you get into place. When we get into Python, we have integer and we have float. Again, other examples, but those are the ones that we're going to talk about. Boolean, simple, always reminds me of Jolene, by Dolly Parton, but that's a whole different thing. So we got true and false. Simply tells us whether or not something is true or false. And we use these statements all the time to quickly sort our data. Is it type whatever, yes or no? Put it in 2 buckets, and then we're off to the races. So that's our friends, the Booleans. Loops. Kind of like hula hoops, but different. So it repeats the same code until you tell it to stop, or the program tells it to stop, or a particular requirement that you give it is met. So if we're working inside of C#, some of the ones you'll run across are for, a while, a do while. It's like a do-wop, but not as fun. And then with Python, we've got some for and some while. Conditional statements. So we're talking about some logic. So inside of here, we have what we see inside of Python. So we have an if statement, and it's hard to read on the big screen there, but basically what it says is, what type of software are you? If you reply Revit, then the answer is, wow, you're cool. Else if, or elif, which means if it's not the first one, it could be the second one, I'm AutoCAD. Oh, you're old. The third one, I'm Dynamo. Oh, you look like spaghetti. And then the else at the end is, if none of those answers are input in, the catch-all for everything else is, I don't know who you are. So, if, elif, or else. C#, exact same thing, except we decided to spell out else if instead of elif. Process exactly the same bit of code, the same bit of logic that we put into place. Some operators. So we've got our arithmetic, pretty self-explanatory. The modulus is the bane of my existence. It's not a percentage sign. Essentially what the modulus means is that it's the remainder when you do division. So if you divide, I'm trying to think of a good example. If you divide 5 by 2, you get 2.5. The modulus of that is 1. Because the whole number I get from that is 4. You take 4 away from 5, the remainder is 1. So that's our friend, modulus. We've got our conditional relationship, logic, green, our friend C#, we went down the code route. Python made it a little bit easier. Is it an and condition? Is it an or condition? Or is it not conditioned? Again, part of we're starting to see why Python might be a little bit easier to read, because I know what an and condition is. I know what an or condition is. I don't know what an exclamation is. Apparently C# is excited about a not condition. Reserved words. We talked about how variables, and we can pretty much name them whatever we want, and there's always a caveat. You can't do what you want. So we have some reserved words, some words that you can't use because they're tied to other things, hard-coded. Once again, Python's a little bit easier because we don't quite have quite as many in place. All right. So now that you're all programmers, because you went through the 101 class, we're now going to take a look at some examples. And so this is a real-life, albeit not that exciting, example that I did with my limited coding skills. So, we have to start with the problem. So my problem is, I do a lot of teaching for my job, and I teach the same class 30, 40 times a year. And I have the same data set, so I want to change the name of the data set by just putting a simple extension on the end of it so that I don't overwrite the original data set. 35, 40 Revit files, doing it manually is a pain in the butt. So what I want to do is I want to find a way that I don't have to do that. So that I can go from on the left to on the right, throwing in my initials. Before you ask, it's Gordon. So I put my initials in there, I now have that in place, so that's what I want to do. So step 1, the problem. Step 2, plan to code, code to plan. I didn't make that up, but it sounded good. So this is where we work out the solution of the problem, pseudocode, flowcharts, whatever. Typical on-the-fly fashion, I skipped it. So I didn't bother doing this, I just dove right into everyone's favorite part, Google. So this is where all the magic happens. There's always more than one answer, especially when we're talking about code. If you're being specific to a Revit problem or something like that, perhaps a little less, but just general code, there's 15 ways from Sunday to find a problem. And if you don't succeed first, Google, and Google again. So, we pop up Google, we type in what we're looking for. So, I want to find a way to rename files in Python. The Google machine returns a YouTube video that says, hey, spend 5 minutes, learn how to do this. So once we've spent 5 minutes and learned how to do that, we get a piece of code, and it works. I type in a few lines of code, and it changes the name. The problem with that, though, is it changes it in the same spot. So it didn't change the name, it overwrote the name. So my original file is now just called something else. Not what I wanted. So then I amend the code just a little bit, and now what it does is it not only changes the name, but it moves the file. So now I don't overwrite the original, and it puts the new one in a different spot with a different name. So now we review. Is that what we want? Is that really what we wanted to do? All right. Am I brave? Let's be brave. So now let's see what that actually looks like. Hey! All right. Oh, not brave. There we go. So this is the IDLE, or not. There we go. So I open up my little program, file, open, file, open. The world's coming to an end now. There we go. Navigate to my examples, Python, say OK. So it pops up and it basically explains that it's going to take the top Revit file and it's going to turn it into the bottom Revit file. The caveat here is that the file has to be in the exact same location that the code is stored for it to work. Hit F5, tells me it's done. I go into my location. And you'll see it now has CGS on the end. Super exciting stuff. I can hear the excitement out there. Now, if I go back in here again, take this back, you'll see I have a new folder. There's nothing in it. So now I open up the other version. Say OK. F5. So now F5, now that it's open, tells me that it's ran. I go back into my downloads. Bam! And we're there. Hey! Look at that. 2 lines of code. Except I'd have to do that 35 or 40 times. All right. So we are back to the drawing board. Maybe. All right, so we know what it just did because we just did it, and I spent more time in C#, so why don't we go down that route? So we go back to step 3. We're going to do a little bit more Googling. Rename files with C#. Very inventive with my Google searches. So, as I mentioned, there's tons of answers and possible ways to get this. So first, I get another video. I read the video, not quite what I want. Then I go to our good buddy Stack Overflow, some good suggestions, a little bit of a flame war, but still not what I really wanted. .NET Peril, awesome website, not exactly what I wanted. This also comes down to having a better search criteria than just rename in C#. Another website, nope. One more time, video, close, not quite. Nope. So finally I get to the C# documentation from Microsoft. Maybe I should have started at the source right from the beginning, but where's the fun in that? I go from there and they have exactly what I'm looking for. Even better, because it's on that, they have the source code that I can just hit the little copy button and it copies it to my clipboard and I can open my Visual Studio and paste it in and I'm already there. I didn't have to type it out, I didn't have to do anything, it's already there. And I'm not stealing, I'm borrowing freely. So we open up our Visual Studio, we start a new program, we paste in what's there. Of course, it's not going to work exactly as I want. I'm going to need to make some changes to it. And we also notice that the nice people at Microsoft coded it so I can understand what's going on inside of it. I make the changes that I need to make so that it works for me on my computer and my happenstance. So before we start, we see that in my downloads, we've got the student files _m. Up in Canada, it's always the metric. I run the program, doesn't give me any issues. After it, we see that we do in fact have the class files _m, Everything has been moved over. We take a look inside of it, and we see that we now have all of the code with the CGS after it. Yes, very exciting stuff. So, one more time, we are brave. There we go. We open up the file in C# and we're not showing you it. All right. So we open up the program in C#. This is what it looks like. And essentially all it's doing is it's taking one file as an example file. And it says, with this file, what I want to do is find out where that file is. Tell me how long that file is, so it's telling me the length of the string. Then it says append or add to whatever the length of that string is, so every file has a different length. So that's where the length of the string comes into play. So this file has 10 characters, this one has 5, this one has 100, doesn't matter. To the end of that, add underscore CGS. And then execute. So it does it once. And if it's happy, if it works, it then says take everything in the first file, location, do it to every file in there, and not just Revit files, any file in there, and then put it in the new folder. If the new folder doesn't exist, create that new folder. So I've got it all set up. I say run, does some thinking, pops up a little console window, and then it says press any key to exit. That means it executed. No warnings, no flags, nothing came off. I go back into my folder. I go into my C# example. You'll see there's now a class files. And everything, including my doc, my template file, my text file, my DOG, everything has been renamed. So, we found a solution. So we find a solution that works. There's no interface though. So might not be something to share with the company, but it works. Another caveat or side step to this is one of the things that we were talking about this whole code-ish thing is that know when we shouldn't do something. And if I had done a simple Google search for bulk renamed documents, there is a free tool out there that does a bang-up job of this with any file format and a beautiful user interface. So you win some, you lose some. But I learned how to do that along the way, so I'm going to take that as a learning moment and that I got things done and a chance to put Borat into my presentation. So really great success for all. So we're bringing this in for landing. Some final thoughts. So remember the steps. It's all about the problem. We need to have a problem first to begin. Solve the problem. At least how you know to do it before we get into the program. If not, do research to find out how to solve it. We need to have an answer before we write the code. Write the code. Test the code. Celebrate success. If you don't have success, go back to 1 and start over again. It's an iterative process. It's a loop, if you will, and we all know what a loop is now. As I mentioned before, there's so many languages, so much stuff out there, so don't get down on yourself. Once you learn one language, I was made sure to put in the ish inside of there, you start to get the idea. A lot of the things are very similar. There are methods, there are loops, there are variables, things that are very similar from one language to the other. English, French, Spanish, not exactly the same, but you start to understand how a language works, so then some of the stuff becomes easier. And one of the ways to look at it is, I just got a new car, it's a little bit different, how do I drive it? Going from manual automatic, from Tesla to not Tesla, however you want to do, but learning that process. We don't have to start from scratch, we have some fundamental understanding. I mentioned XKCD, this is a great one, so beware of reality. I'm going to write some code, it's going to save me so much time, I can basically only work 2 days a week now because my code is awesome. The reality, That isn't how it goes. You spend so much time thinking about the code, thinking about making it better, that you don't have any time to actually do what you started off doing when you used code. Now, Randall, who does XK or XKCD, doesn't just do funny stuff, a lot of funny stuff, but this is an awesome slide that he did as well to help you know when is enough when you're working with something. So across the top is how often do you do something. Across the side is how much time the code is going to save you, and then the whole thing is aggregated over 5 years. So if you do something and it's going to take you, it's going to save 1 second of time, but you do that task 50 times a day, if you spend 8 hours on that, the ROI is worth it. If you do something 5 minutes a day, and you do that 50 times a day, well then you can spend 9 months working on that code, and it's still worth it. So that's really what this is trying to point out, and sometimes it's just not there. I taught a Dynamo class a couple years ago at RTC, and I walked everyone through an example, because we were in Toronto, so you'll understand in a second, how to create a hockey rink in Revit using Dynamo. It took us an hour. At the end of the class, I said, could any of you have made that faster inside of Revit? And of course, everyone's hand went up, because they could have done it with Dynamo Graph in 5 minutes. So coding, programming, Dynamo isn't always the answer. And just knowing where to draw that line, where it is, puts you well on your way. So remember at the very beginning we talked about why I got into this tweet from Gordon. Well, it's a double-edged sword. There's 2 sides to every story. Carl, tell us more. What do you mean? Well, I think the best way to explain it is to go back to our friend Gordon Price and have him explain it. And this wasn't a plant. He tweeted this a couple of weeks ago. Some days I really wish that I did major in computer science because I bang my head on logic that I'm sure first-year computer programmers know super easy. That comes down to the part of know when you don't know what you don't know. And sometimes it's hard not to know what you don't know, but if you've done enough tweaking, playing along the process, you know that, okay, this is over my head, it's not for me, move it on to something else. So that's really where we're trying to get to at this stage. And with that, I will bring this in for a landing and ask if anybody has any questions. Wow, it's just like Grasshopper except crickets. Well, I'm here for another 5 minutes or so. If anybody has any questions, feel free. I will be in the speaker lounge at afternoon tea if anybody has any questions there. Please also